applications of matrices and determinants. So in numbers 1 through 6, it says use the determinant to find the area of the figures given. So number 2, if I were to do a rough sketch, -3, 5 would be here somewhere, 2, 6 would be here, 3, -5 would be here. So if I look at this shape, I realize that this shape is going to be a triangle. Remember, to do a triangle, the formula is plus or minus 1/2. That plus or minus is just going to make my answer positive because an area has to be positive. Then I'm going to do the determinant. I'm going to put in my ordered pairs, and it does not matter the order that I put these ordered pairs in. And then I'm going to follow it with the last column of ones because it has to be a square matrix in order to find the determinant. If I just use the ordered pairs, I wouldn't have enough numbers. I'd have a 2 by no, I'd have a 3 by 2, and that's just not going to work. So now I'm going to get out my calculator because we can do these in our calculator. And I am not going to do the plus or minus. I'll handle that later. I'm just going to do menu, matrix or vectors, go to number 3, which is a determinant. I have created a 3 by 3, so these values are fine. And I am going to type in what I wrote here, which is, I just want to make sure I went in the same order. So here we go. So -3 does not matter the order that I do these in. 2, 6, 1. And when I hit enter, I get a -56, which is fine. That's great, actually. So I get a -56. So this part here is a -56. So I'm going to have the plus or minus 1/2 times a -56. I want my answer to be positive, so I'm just going to take half of 56 and get 28. And so in this case, I had to multiply by -1/2. I do whatever I have to do to make this positive. So the area is going to be 28. Number 5 is a little bit different. It is a quadrilateral. It has 4 sides. But in order for us to use the determinant, I'm going to have to separate it into 2 triangles. So it does not matter the way that you separate into 2 triangles. You just have to keep track of which pairs that you're using. So I decided to make my triangle like this. So when I did that, my points on this triangle were -3, 2, then 1, 2, and then this final pair down here is -5, -4. And that's this -3, 2, 1, 2, -5, 4. That's this triangle here. So I'm still going to do the plus or minus 1/2. Now I'm going to have another triangle. I'm going to have this triangle down here, and let's switch colors for that. Let's make that blue. So I'm going to start here, and I'm going to start with -1, -4, and then 1, 2, -5, -4. Oh, and I forgot to put my column of ones up there, so let me sneak those in. Okay, good enough. So, and this is going to be plus or minus 1/2. So on my calculator, I am going to do both those determinants, and then I'll come back and figure out what I'm doing. So I am doing the red one first, so I'm going to hit menu, vectors, well, not that. Determinant, again 3 by 3, so that's good. And then I'm doing those first order pairs. Now if you did the triangles the other way, you're still going to get the same final answer. You're just going to have a different workflow because your partial areas will be slightly different. But you're still going to get the same thing at the end. So I'm going to do both of these at once while I'm sitting here. So menu, vector, determinant, 3 by 3. And then I'm going to do the second triangle, which was -1. No, it's -1, and I said -4. Oh, I should have done that. Oh, well. So I get -24 and +24. So when I go to do these, that's good. Which, so This one was negative 24, so this will be plus or minus 1/2 times 24, negative 24. So I'm going to do the negative and make this a positive 12. And then this one was plus or minus 1/2 times a positive 24, which is going to be 12. And when I add these together, I'm going to get an area of 24. That's just a coincidence that those two happen to be the same. That doesn't always happen. Okay, the next one, it says find x so that the triangle has an area of 4 units. So negative 1, 5, negative 2, 0, x 2, column of ones. And when I take plus or minus 1/2 times the determinant of this, I want to equal 4 square units. Well, if I multiply to get rid of this 1/2, if I multiply both sides by plus or minus 1/2, no, 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 no. Okay, number 7 says find x such that the triangle has an area of 4 square units. So the first thing I'm going to do is I'm going to find the determinant of these points and then figure out what I'm going to do with the 4 square units later. So I'm going to have negative 1. So I'm going to have negative 1, 5, negative 2, 0, x 2, column of ones. I'm going to since I have that x in there, I cannot do it on my calculator. That kind of eliminates that because I can't put the x in. And before you even ask me, no, I don't know that NSOLVE will work. So I'm going to do negative 1, negative 2, x 5, 0, 2. I'm going to go back old school and do the determinant by hand. So I'm going to take these, which when I do that, I'll have 0 plus 5x minus 4 minus, now I'll do the other loops. So that's 0. And when I do that, I'm going to have 0 minus 2 minus 10. And I'm going to set that equal to, we'll put a little question mark there for a second. So I'm going to have 5x minus 4. When I add these two, there'll be negative 12. So this will be plus 12 is equal to question mark. So I'm going to have 5x plus 8. Now let's go up here and see. We took plus or minus 1/2 times the determinant, and we set that equal to the area of the triangle, which in this case is 4. So this is my determinant, it's plus 5x plus 8. So when I go to do this, so let's say this was like, I'll call this D for lack of anything else. If I multiplied by a positive 1/2 and set that equal to 4, then the determinant would be equal to 8. If I set that, maybe I had to multiply by negative 1/2 times the determinant, and that was equal to 4, then the determinant would equal negative 8. So when I go to solve this, I am going to actually have to set it equal to 8, and I'm going to have to set it equal to negative 8, because there's two possible answers. One could be when it was positive, one could be when it was negative. So when I do this, when I subtract 8 from both sides, I get 5x is equal to 0, x is equal to 0. When I do this one, I subtract 8 from both sides, and I get 5x is equal to 16, x is equal to 16, negative 16, negative 16 fifths. And those are my two possible answers for x. Again, a quick way to check would be to put in 0 for this, see if you get, in this case, 8, or you could put in negative 16 fifths for this x and see if you get negative 8. Both those answers are correct. The next one says use the determinant to determine whether the points are collinear. So remember, it's trying to see whether or not they make a triangle. If they make a triangle, then they're not collinear. If I have 3 points that form a straight line, then they don't make a triangle. They are collinear, which means my determinant would be equal. If I have 3 points that go like this and one of them just pops out a little bit, then I have an area inside this triangle because 3 points make up a triangle. So when I go to do this, I am going to try and erase, but not. I am going to set this up just like I would an area problem. last column full of ones. I'm going to put this in my calculator. I'm going to find the determinant. If it's equal to 0, I say it's collinear. If it's not equal to 0, then I say it's not collinear. So I'm putting this in. I hit enter and I get 0. So I am going to say that this one was equal to 0. So those points are collinear. Now I'm going to do the same thing for number 10, 3, -5, 6, 1, 4, 2, column of ones. I'm going to go find that determinant and see what I get. Haste makes waste. And when I do this one, I get 15, which is not 0. So they are not collinear. And that's all you have to do to determine if points are collinear or not. Okay, moving on to number 14, it says find x such points are collinear. So I'm going to do -6, 2, -5x, -3, 5, last column of ones, and I want this to equal 0. So I have, because of that x, I have to do it old school, and I have to copy down my first 2 columns. And then I'm going to do the loops. And when I do that, I get, okay, now I'm going to combine like terms before I go any further inside the parentheses. So I'm going to have -6x minus 31 minus, and then this will be -3x minus 40 is equal to 0. Now I'm going to distribute this negative sign, so I'm going to have -6x minus 31 plus 3x plus 40 is equal to 0. Combining like terms, I have the -6x and the positive 3x, that'll be a -3x. And then I have the -31 and a positive 40, so that'll be +9 is equal to 0. It's linear, so I'm going to take 1 over to the other side. I decided to take the 3x to the other side. So I'll have 9 is equal to 3x, divide both sides by 3, and x is equal to 3. Again, to check it, I will put the 3 in here, see if I really do get a determinant of 0. Okay, and the last couple are using Kramer's rule. So we are going to do these on the calculator, but I want to show you what you're doing. You are going to first do the coefficients. So my coefficients are -7, 11, 3, and -9. I'm going to find the determinant of that, and when I did the determinant on my calculator, I'm skipping ahead. When I did the determinant, I got a determinant of 30. I did that on my calculator. All's good. Then when I want to go find my x's, when I want to find x, I write myself a note of what I'm doing. So I'm looking for x. I'm going to say x is equal to, I'm going to take the answers and I'm going to put those in the x column. So -1 and 9. The other column stays the same. And I'm going to divide that by this 30 here. And when I did that, again, putting that in my calculator, I got a -90 over +30, which gives me an answer of -3. To find my y's, I'm going back up to this matrix here. The x column will stay the same, but now in place of the y column, I'm writing the answers, -1, 9. And I'm dividing it by that same coefficient determinant, which is 30. When I did this on my calculator, I got -60 over 30, and I get -2. That's the answer. 18, again, I'm going to fly through this one pretty quick. 6, -5, -13, 3. Those are my coefficients. When I did the determinant of that, I got a negative 47. Then I'm going to use that negative 47 for both the other ones. So when I go to find x, in place of this x column, I'm going to write the answers, which were 17 and negative 76. Leave the y column alone. And I'm going to divide that by that negative 47. And when I do that, I get a negative 329 over negative 47, which will be a positive 7. To find the y, again, going up to my coefficients, the 6 and the negative 13 stay the same. In place of the y column, I write the 17 and negative 76 and put that over negative 47. This ends up being a negative 235 over negative 47, which gives me an answer of 5. So my ordered pair is going to be 7, 5, and over here it was negative 3, negative 2. Okay, the next one, again, I'm just going to write down what we do, and I didn't do it yet, so we'll do it on the calculator because I want to show you a trick on your calculator because this is a lot of typing on your calculator. So that's going to be my coefficient, and then my x is going to be 10.8, 24.8. Those are my answers, and then the y column stays the same, and then I'm going to divide that by whatever I get here. And my y is going to be that 2.4, 4.6. Those are my x's. Then I'm going to put my answers in for my y. And I'm going to divide it by, again, whatever I get here. So let's see how I do this quickly and efficiently on my calculator, shall we? So I am going to take out my calculator. I am going to hit Menu, Determinants, and then I'm going to do the determinant of a 2 by 2. So that was 2.4, negative 0.8, and then this is 4.6, and this is 1.2. When I do that, I get 6.56. I'm just going to leave that there for a second. And now I'm going to go up and I'm going to grab this from before. So I'm going to go up and I'm going to grab it. Now the y column is staying the same. The x column is what is changing. So inside the x column, I'm putting the answers, which were 10.8. And then my y answer was, or the second answer was 24.8. And when I do that, I get 32.8. Then to find out what x is equal to, I'm going to take this 32.8. So I'm going to go up and grab that answer. And I'm going to divide it by that 6.56. And I'm going to get 5. So let me do the other one before I go write everything down. Now I'm going to go back up and I'm going to grab the coefficient matrix, this guy right here, the one I started off with. Now, to find the y's, the x column will stay the same. That's why I didn't go up here because I'd be retyping the whole matrix because I changed the x column last time. And now my answers are going to go in the y column. So I'm going to put 10.8 here, and I'm going to put in 24.8 here. Hit enter. I get that 9.84. So I'm going to take that 9.84, and I'm going to divide it by that 6.56, and I'm going to get 1.5. Sounds much, much better. And so my answer is going to be 5, 1.5. That's going to come in really handy when I go to do the next one. So this next one is a 3 by 3. So I'm going to do this on the calculator, but now I have to find my x, my y, and my z. So to do that, I am going to have to do 4 determinants. I'm going to have to do a determinant for the coefficients, a determinant for the x's, a determinant for the y's, and a determinant for the z. So I am going to do my coefficient matrix first. 4, 2, 5, negative 1, 2, negative 2, 1, 3, and 6. And I'm going to go find that real quickly. So you're coming with me. So those are just my coefficients, and that's 55. So then what I'm going to do is I am going to find the x and the y and the z determinants, and I call them the determinants. So this was 55. So then to find x, let's do it this way. The x column changes to the answers. Everything else in this matrix is going to stay the same. And then I'm going to divide this by 55. And this is me finding the x's. So when I go on my calculator and I put that matrix in, I'm not going to retype the whole thing. I'm just going to go up and grab it. And I'm going to replace that first column, the x column, with the answers. And the answers were -5. And then you're going to go down here and make this 10. And you're going to go down here and you're going to make this 1. You're going to hit enter and you're going to get -55. So I am going to make this -55 over 55, and I'm going to get an answer of 1. Now to find the y's, my 4, 2, and 5, that x column is going to stay the same. Now the answers at -5, 10, and 1 are going to go in the y column. Everything else stays the same, and I'm going to divide it by that same 55. So when I do that on my calculator, if I want to go back and grab, I'm going to go back up to the original one, which was the coefficients, because that way I'm only changing the second column or the y column. This is -5, this is 10, and this is 1. Hit enter and I get 165. So now I'm going to take 165 and divide that by 55, and I believe that's 3. And I'm going to get 3. Last one I have to do is z. Well, this is getting pretty easy now. To find z, the 4, the 2, and the 5 stay the same. The -1, 2, and -2 come back from up here. And now the answers go into this column here, -5, 10, and 1. Okay, and we're going to do that in a second. Hold on. Okay, so I'm going to put this in my calculator. Remember, to do this, I have to go up and I'm going to go up and grab the one that was the original one that had the coefficient matrix, because that way I only have to retype one column. If I do another one, then I'm going to end up retyping 2 columns, because the answers only replace that one column. So when I do this, I type this in, I end up with 110. So I'm going to go over here and I'm going to take 110 and I'm going to divide it by 55. And I'm going to get 2. So my solution